Hello and welcome to the Mason Storm DIY audio channel. In this video series we're making some hi-fi speakers. In this video we are going to be assembling the crossover. Have my soldering iron turned on there, got my data sheet, and let us begin. So over here where I'm pointing, this is the woofer portion, and it consists of an inductor and a capacitor. The inductor is in series with the speaker and the capacitor is parallel to it. So one of the things you can do once you have your inductor is to measure it with an LCR meter to see if it is what it says it's supposed to be. So disconnect the leads of the inductor to the LCR meter, and we have our 2 millihenries, which is what we were aiming for. And when we were ordering our capacitors, they didn't have the right size, so we ended up having to get 2 different sizes, and we'll put them in series, and that will increase the overall capacitance. So just kind of laying them out here, trying to get the camera to focus to read the numbers on there. Something different will have to be done for the next one when we doing some soldering or any of this like close-up stuff, because it is just terrible to get it in frame. But so anyway, we'll take those, we'll join them together, get a nice physical bond, and then get our meter out here and we'll put them on the test. I did fiddle around with this for about 20 minutes, and it it turns out that my meter isn't able to measure capacitance up to the values of the combined capacitors. And as you can see, it says overload OL, but it took me a while to figure out what that was all about. But I didn't make you sit through all that because it was kind of painful. So there's enamel on the the magnet wire of the inductor, so I'm just using these pliers here and just kind of touching them down and then kind of dragging to kind of scrape it off. But it's probably better to actually use like a lighter, and you can kind of burn it off, and that usually works quite a bit better actually. But I didn't really want to have a lighter underneath my camera. It's good to have a good physical connection beyond just a soldered connection, because you can technically just kind of tin both leads and then bring the leads together, then reheat both together at the same time, and that'll get you a bond, but it's not the strongest one. But if you wrap the wire around and then you solder it, you have a much stronger joint. And I like to try to lay out my components for the crossovers in a design kind of similar to how it is on the data sheet, just as part of that kind of sanity check thing. And that's kind of what we have going on here. It's possible too to like shorten the wire on the inductor. It doesn't really need to be all long like that and loopy, but I didn't really decide on how I was going to mount the components on a board at this point, so I just kind of left it as is. And it's not like it hurts anything having it a little bit long like that. I can just kind of bend it up or whatever after the fact and kind of get it into any kind of shape that I want. But just kind of getting that other lead all prepped there. So and I'm going to use speaker wire, so I'm going to run speaker wire from the terminal on the back of the speaker to each individual component on the crossover, and then the crossover on the other end will be connected to the actual speaker. And I find speaker wire works really good for the inside of a speaker just as well as it works on the outside. Manufacturers, when they build speakers, they don't ever do that, but as far as getting a decent gauge of wire, and it works okay. It's not that bad. The trick to the soldering is to heat everything up and then kind of let it flow. So I was trying to have my soldering iron in frame here, but I have the temperature quite a bit hotter than I normally would for when I'm doing more electronic things like assembling boards or whatnot. Because well, the gauge of the inductor, I mean, that's nothing too crazy, but when you're trying to heat up like a big thick wire, you need a lot of heat to kind of heat it up quick enough that you're not just heating the entire thing up, to be able to get the solder to kind of flow. I have nice thick rosin core solder right there. I actually bought that by mistake. I mixed up the millimeters and decimal inches, and I thought I was getting nice fine wire for doing the small PCB stuff, but it turned out to be quite thick. And I think I got 5 pounds of it or something like that, so lifetime supply. But for doing the heavy gauge stuff like here in the crossover, it works pretty good. It's well, it's a use of it anyway. I mean, because when you're doing the fine soldering wire, you go through a lot of it. But rosin core is what you want. You don't want acid core, because acid core, that's for doing pipes and stuff, and as far as I know, it can actually like damage the components. So, you know, if the acid core kind of wrecks your capacitor and stuff starts sounding a little bit weird, it's kind of problematic. So we have the input side with the speaker wire connected, and I'm going to do the output side on the woofer portion of the crossover. Same idea, just wrapping it to get a nice good physical connection, and then I'll come back with the iron and flow some solder. It's important too to get your polarities right on your schematic. So I have the schematic out of frame, but I'm looking at it as I'm going just to make sure that I got everything kind of the way I want it. The other thing you could do would be to have a labeler and actually label your in and your out. That way when you're actually assembling it, you know, who knows how many weeks later or whatever. I mean, stuff happens, but you kind of know what things belong where. Just kind of heating it up and just kind of dabbling the solder in. Yeah, it's tricky to get in focus. But there we go. That is the first section of our crossover. That is our woofer. We have our series inductor and our parallel capacitors. And we have our in and we have our out. And I'm actually going to be doing cardboard mounting, which actually works surprisingly well, because cardboard is actually a wood product. So wood glue actually sticks to cardboard very well, and it doesn't rattle. Like if you had a piece of wood and you mounted it inside of your case and it wasn't quite flush or wasn't quite right, I mean, you could have the vibration of the speaker cause some sort of rattle, whereas with cardboard you don't really run into that. Just kind of double checking that I got it right with the schematic, and kind of pointing out each part of it here. Inductor, parallel, there we go, there's the join of the two. Oh yeah. It all makes sense now. There we go. Part 1 of 3. And the other thing with the cardboard, although it's not actually cardboard, that's corrugated paper, is that it's possible to separate the two layers. So if you ever had to take the speaker apart, you can kind of get in with like a putty knife or something in between the two layers of the cardboard and actually just split the whole thing and pull it all apart. So it usually works pretty good. Doesn't look as good as the using like a 1/4-inch plywood or something, but it is what it is. It's always a trade-off. But as far as performance and price goes, cardboard is probably king. So the mid-range, which we're doing right here, it's got a low pass and a high pass filter because it filters below with how it connects to the woofer, and it filters above for how it's connecting to the tweeter because it's a 3-range system. So this is this particular board will be the most complex one of the crossover. So it actually has the most components in it, but it's not really a big deal because you just you start at one end and work your way to the other, and if you kind of lay it out visually, like that's kind of what I like about the grid on this craft board or whatever they're called, work board, is that you can kind of have a grid layout and align everything to it and get it all kind of perfect the way you want it. Just kind of taking off that enamel there so that the inductors will solder. The only reason why I point that out multiple times is that I've done it before where I thought I sanded, well, I guess that's the other way, you can sand it off. You can burn it off, you can sand it off, you can scrape it off. But I thought I sanded it off and I didn't, and it's just like the solder wasn't sticking, and then I tried cranking the soldering up to 900 or whatever, and it took a lot of energy to be able to get the solder to flow. So I think the other thing is too, like if you can get the solder on like the actual tip, like the very end of the wire, then you can kind of heat it up and you kind of wick it down, and yeah, it's ugly. You're better off preparing it properly. So the thing with our mid-range here is that we actually have a resistor out front, so that's going to be kind of a series resistor. So that's going to actually lower the overall amount of current going through the particular system, so that lowers the overall volume of it as well. So it's actually got more than 2 parts of filtering. So we got our attenuation filtering, and then we have our low pass and high pass filter. So I guess it just kind of takes it to the next level. But our CAD program, that's kind of what it was saying to do, because it's all physics. Here we are. So we got our different sections there. So we got our resistor going to our capacitor connected to the 2 different inductors, the one's in parallel, the other one's in series, and then the capacitor that's in series, it looks like it's connected to our other capacitor there. So it's just multiple components. And there we go, we'll get the wire ready and we'll do our input and our output. Kind of enjoy doing the crossover stuff. It's kind of therapeutic because it's like as far as soldering goes, it's probably about, you know, one of the easiest things as far as soldering difficulty goes compared to like trying to do surface mount devices, or well, even through hole is usually pretty easy, but this is even easier yet. It's all about positioning, getting good positioning, getting good prep and your physical connection, and then just kind of soldering in and just kind of heat it up and flow it in, and you have a nice solid connection. And that's why too, when I do the crossover, I usually get the thing all made up and then I solder it last, but because I get the good physical connection going, it doesn't all fall apart, so it's not like I have to solder as I go. And then once everything's kind of held together by the solder and the physical connection, you can kind of bend stuff all over the place to try to get it the way you want it. And as far as inductors go, it's a kind of best practice to have them in different orientations. That way they don't they don't work as a transformer. You don't want the magnetic field of one impacting the other one, so you face it a different direction, like 90 degrees off, like one vertical, one horizontal, like that, and that way you don't get any mutual inductance, because that could give you some degree of interference in your system. And that's also one of the benefits to doing the triple crossover approach that I use, with having the low, medium, and high all on its own little board. Because then when I'm putting them inside the case, the enclosure, I can put them all in different locations. I can have one on one side, another on another side, and the third on it, like, wherever. It's sky's kind of the limit. Whereas if they're all out together on one board, which is typically how they're done, like when the speakers are manufactured by companies, because it's, I mean, they just get one board made, they throw everything on it, and they're good to go. But again, one of the advantages to doing the DIY is that with really low manufacturing quantity, you don't have to. You can do whatever you want, and even if it takes more time or a little bit more money. So I didn't have the right value of capacitor here, or sorry, resistor, so that's why I got two resistors in series before the capacitor. And here we go with our inductors. So this is the crossover portion for the tweeter. And you can see when I fold that stuff around like that, the actual footprint of the crossover is like tiny, which is it's kind of handy. Not that there's any shortage of space whatsoever, but it does work. But then we just need to get our input and output going here. So let's solder our wire on there. Yeah, one thing I definitely regret about the way I kind of did this crossover, I should have thrown some labels on the input and output with like the label maker, because it just makes everything a lot simpler. But I mean, each device only really has two, so it's not really a big deal. And generally the resistor as the first item is that's always the way I do it. So I just look for the resistor, and then I know which is the input and which is the output. And as far as if you wired everything up backwards, that would be okay. But if you had some things backwards, some things forward, then you'd run into like a bit of a polarity issue. So it's best to just try to get everything right. I do recommend testing the connections of your components. So giving them a little bit of a tug and make sure that nothing's loosey-goosey, and just kind of go from there. And here's the second set of crossovers here, and I've kind of sped it up, because I think I have a bit better of an angle, so I might be able to see a little bit more in this portion. What I'm going to show you here is some crossovers from other speakers I own, B&Ws, JBLs, and some Sabos. Probably around the $1,000 range for a pair, and that's what the crossovers look like in them. And the thing to notice is the zip ties on the inductors and this elastic on the capacitors. But really not a whole lot going on. It's just fastened to a board and the board's fastened inside. But here we go. Here's the real deal. Here's the technique that I'm going to be using, the Bondo on cardboard method. I don't know if this method's really recommended that much, but it's quite cheap, and I didn't have zip ties on hand, so this is what I ended up going with. So it's just a matter of getting square chunks of cardboard, plastering them with lots of Bondo, and sticking everything on, and just leaving it to cure. So it's quite simple. The Bondo sticks a lot better than hot glue does to the cardboard, and once it dries or cures, it's not going anywhere. Like, you don't want your stuff falling off the board, and the glue really holds the cardboard to the enclosure, and the Bondo really holds the components to the cardboard. So, and if you ever have to remove everything, you can split the cardboard in the middle. I guess it's technically corrugated paper, right? Split the corrugated paper in the middle, and then you can glue it again to something else if you wanted to, if you decided to change your enclosure size or something. But it kind of is what it is, but it works. The other ways to do it would be to glue or zip tie and use like a board rather than cardboard, but I really like how the cardboard can't rattle inside the enclosure. I find that quite helpful. I just want to emphasize that. Something to keep an eye on when you're doing this is you probably want to have it so that where the cords are attached that go to either the drivers or the terminal blocks, that they're kind of secure to it as well, because you don't really want, you know, it to dangle in such a way that a little bit of tension on the cable and you're yanking the capacitor in half. Like, it's not good to have it do that. And the other thing too, when you're working with Bondo, is the amount of activating agent you put into it determines kind of how fast it kind of settles. And I was a little bit aggressive on how much I put in, so I wasn't able to do it all with one batch, because it all kind of hardened on me and kind of prevented me from finishing what I wanted to do. But it works out pretty good. So just kind of chip away at it, get everything laid out on the cardboard with the Bondo holding it in place, and on the mid-range crossover where we have the two inductors, just have one of them 90 degrees to the other one, and have them kind of spaced out as far as you possibly can. And that's kind of the optimum solution for making the crossover work. Yeah, like, look at that stuff. It's just so much wasted Bondo right there. But yeah, probably smaller batches would also really help, but oh well, get it right the next time. But a lot of different ways you can do the crossovers, and cardboard's probably the cheapest. Well, that was fun, but now we got to get them actually inside the speaker. So what I'm going to do is tape the three of them together, and then I can get them inside the enclosure, and then glue them all in place. So the tape just kind of holds all the ends together. That way I've got one point I've got to solder as far as the input goes or whatever on the terminal block. So get everything in place, get it all in the box, and then kind of lay it out. It was really hard to film that, so I'm just going to take a couple pictures of kind of where I ended up with. But just kind of space things out. It's kind of a good idea to aim for having each one kind of near where its respective location. So having the woofer under the woofer and the mid-range under the mid-range, or on the wall towards where the mid-range is, and just kind of working it out that way. As far as gluing them in, this amount of glue is not enough. I ended up putting a lot more on, and I'll show that in a later little clip, because this wasn't enough glue to kind of hold, so I ended up lifting them all up and dumping glue back on them. But that's, you can kind of see how I somewhat have them spaced out, and just trying to have everything as far apart as I kind of can. I also didn't leave myself enough wire on the input, so that kind of sucked. On the second speaker I ended up connecting all three wires together, then soldering another wire to it, and that let me have more length, so I'm able to move everything around a lot more. But you can kind of see the general idea of what we're going for. I do got a little bit of paint on the boxes now, but still have quite a ways to go till I'm finished. But just a lot of sanding and Bondo and painting and sanding and painting, but it is what it is. And this is the second set that I ended up soldering together and then putting an extra leg on there. So I got lots of room for as far as laying them out, and I'm just going to show you here how much glue to put on. But this is kind of the end of the video here, and in the next one we'll pick it up, and hopefully I can have some painted boxes and stick the drivers in, and we got some tunes we can listen to. So until next time, stay awesome.